Today I'm going to talk to you about the quotient rule, and the quotient rule is used to differentiate quotients. Well, a quotient is a fraction where you have an equation in the form of y equals a numerator u over a denominator v. You don't have to use the quotient rule, you can always get by using the product rule. However, it's useful to make things instantly factorised on the denominator, and the rule works. Of course, quotients are all rational functions. So let's have a look at the quotient rule. To differentiate a quotient, we say that dy dx equals v multiplied by the derivative of u with respect to x, obviously if the function's in terms of x, take away u multiplied by the derivative of v, all divided by v squared. And that's your basic quotient rule. So let's just set in with an example. Let's suppose I want to differentiate y equals x squared plus 1 all divided by 2x minus 3. As you see, we have a quotient. Let's let u equal x squared plus 1, as seen here, and v will equal 2x minus 3. So I like to do some working over on the left before I sub into the actual formula. And so du dx then over here is 2x. And then I look over at v. Well, v is 2x minus 3. So dv dx is 2. And then I often write v squared as well, just in case that needs simplifying in any way. The best way is to leave it factorised. So v is 2x minus 3. And obviously that's going to be 2x minus 3 squared. And you wouldn't expand because remember most answers should be fully factorised once you finish. So let's substitute into our rule for the quotient rule to say dy dx equals, so v, 2x minus 3 multiplied by du dx gives me 2x first multiplied by 2x minus 3. Subtract u times 2, which is dv dx. So I've got 2x squared plus 1. All divided by v squared, which is down here, which I believe is off your screen, apologies. 2x minus 3 all squared. And all I got to do is expand and try and simplify the numerator. Alright, so 2x times 2x is 4x squared minus 6x minus 2x squared minus 2. All over our v squared. And then let's have a look at like terms. 4x squared minus the 2x squared leaves me with just 2x squared. And I think this is the last line I'll be able to do before I have to rub anything off. Minus 6x minus the 2 all over 2x minus 3 all squared. And then what you do is you look to see if the numerator can factorise. You say, well, can I factorise that? The answer is yes, I can, because I can pull out a factor of 2. Each term has a factor of 2 in there, so I would pull that out. So I'm going to have to write that, obviously, ideally, over here. I'll write it over here. So pulling out that factor of 2, so our dy dx is 2 bracket x squared minus 3x minus the 1 all over 2x minus 3 all squared. And that is as far as it can go, because the quadratic that we've been left with here doesn't factorise. Alright, and that's pretty much how you use the quotient rule to differentiate rational functions or quotients.